One day, Mars could look like this, allowing humans to comfortably live on the planet. All we'd need to do is to terraform it. But how? Well, we could nuke it. Would dropping nukes on Mars make it easier to live there? This is What If, and here's what would happen if we nuked Mars. Believe it or not, this is something scientists have considered for decades. Elon Musk of SpaceX seems to think that nuking Mars might be one of the best and quickest options to make it a place where humans could live. The idea is that we would explode thermonuclear bombs in the sky over the planet's two poles. This would heat up the ice caps and release carbon dioxide and water from the poles. Then the greenhouse effect would take place. It would heat up the whole planet, making the surface more habitable. So this all sounds super quick and easy. Why haven't we done this yet? It's because there's a high chance that nuking Mars might not work out the way we want it to. There are many things that could go wrong with this plan. The first problem is it's all just theory, and the theory could be wrong. That's because Mars has been losing its atmosphere for a long time. Earth's atmosphere is almost 100 times thicker than Mars's, and if we're going to live on Mars, it needs a thicker atmosphere. Some scientists think that we could release CO2 from the North and South poles, and this could make Mars's atmosphere more like Earth's. But a 2018 study published in Nature Astronomy found that even if the nukes are successful, it would only increase Mars's atmosphere to 7% of what Earth has. Even if we create more carbon dioxide in Mars's atmosphere, it still wouldn't be nearly enough to heat the planet. And the planet could seriously use more heat, since its current temperature averages around minus 63 degrees. And it would take decades for the red planet to warm up, even after it gained the extra CO2. So, in theory, this could delay humans from ever landing on Mars. Not only that, but this assumes that dropping thermonuclear bombs on the planet would go perfectly. Keep in mind, these are nukes. You know, the things that can destroy entire cities. In fact, the bombs we'd use on Mars would be 1,000 times stronger than the ones used in World War II. If a bomb exploded on the planet's surface instead of up in the atmosphere, some severe damage would occur. Not only would it completely destroy parts of the planet's surface, it would also cause even more radiation, another thing that would delay us from ever settling on Mars. It's also very likely that instead of warming Mars, a bomb could cause a nuclear winter. This could happen from the dust and particles in the atmosphere caused by nuclear explosions. They'd almost entirely block out the sun, causing Mars to cool down even more. So, nuking Mars probably isn't the best idea. We've heard about terraforming the Moon and Mars as we attempt to colonize space. But what about Venus? If we did manage to terraform our neighbor, one day it could look like this. Could we live here one day? How different would it be from life on Earth? This is What If, and here's what would happen if we terraformed Venus. Believe it or not, Earth and Venus are very similar. At times, Venus is even referred to as Earth's sister planet. They're both roughly the same diameter, have the same mass, same gravity, and are both made out of the same material, a central iron core and a rocky mantle. Unfortunately, the comparisons end there. Unlike Earth, Venus is extremely hot, has an incredibly dense atmosphere, and toxic fumes on its surface. What would we need to do to make it habitable? Scientists and astronomers have been theorizing how to terraform Venus for over half a century. The two biggest issues that need to be solved are the atmosphere and the temperature on Venus. Currently, the surface of Venus is a sweltering 462 degrees, hot enough to melt lead. And the atmosphere, made up mostly of carbon dioxide, is 93 times as heavy as Earth's. One proposed way of altering Venus's atmosphere is to bomb it with hydrogen. Hydrogen bombs, when reacting with the carbon dioxide in the atmosphere, would create graphite and water. This would fall down to the planet's surface and cover 80% of it with oceans. Mind you, they wouldn't be nearly as deep as Earth's oceans. Venus would only have 10% the amount of water that Earth has. This would take a lot of hydrogen. The only way we could get enough is if we were to harvest the resource from Jupiter or Saturn. This approach would also require iron aerosol, a material that can be mined from asteroids. If all went according to plan, the dense carbon dioxide atmosphere would be reduced to being just 3 times as heavy as Earth's. Okay, that's manageable. This would also help clear the clouds of sulfuric acid that hang over the planet. Okay, the atmosphere's clear. Now, what about the temperature? One way to cool the surface is with solar shades, a series of small spaceships or one large lens that would divert the rays of the sun. These solar shades could be placed on the surface of the planet or in the atmosphere, slowly working to cool down the planet and reduce radiation, another issue that would need to be resolved before we started living on Venus. In addition to solar shades, NASA thinks that we could build floating cities above the clouds of Venus. These would work as a safe living space as we learn and attempt to terraform the environment. To cool the planet even more and to speed up the process, cooling pipes could be put on the surface of the planet. These pipes would take heat from the surface and bring it up to colder parts of the atmosphere. Now we have a suitable atmosphere, a proper temperature, and clean air. But there's one other huge issue that humans might have if they move to Venus. They'd have extremely long days and nights, since Venus rotates once every 243 Earth days, meaning a day on Venus is 5,800 hours long. Not to mention, it's the only planet in our solar system to rotate clockwise, meaning that its extremely slow sunrise would happen in the west, and sunsets would be in the east. We could create the illusion of a 24-hour day cycle by using massive mirrors and having them rotate to reflect the sun. If this managed to work correctly, Venus would feel just like home, with maybe a touch less gravity. After all this, Venus would finally be habitable. Sure, the planet would rotate differently and you'd get a different view of the sun, but it could be another place for humans to live. Scientists theorize that it could be a backup planet one day. Studying more about Venus could teach us something about Earth. Venus suffers incredibly strong greenhouse effects, the cause of its extreme temperatures and dense atmosphere. By learning more about cooling this planet, it may unlock the secrets to cooling our own and maybe make our home last even longer.
This is a planetary emergency evacuation. Please remain calm and board your space shuttles.
You know, even though humanity might not have to leave the Earth in your lifetime, we should start preparing early on. Not only could it take centuries to set up the relocation program, it would take generations to move to a potential new home. That right there is Proxima Centauri B, or just Proxima B. It's the closest potentially habitable planet out there. Its temperatures are in the bearable range and it could have just the right breathable atmosphere. We only have to get there. How long would our journey last? How many people would we send to populate the new world successfully? And what if it turned out that Proxima B wasn't as habitable as we thought? This is What If, and here's what would happen if we relocated humanity to Proxima B. When astronomers started finding planets outside our solar system, or exoplanets, we realized that there are many worlds out there. That meant that Earth doesn't have to be our home forever, and that we don't have to die with our planet when the sun engulfs it some 5 billion years from now. Now that we've found over 4,100 exoplanets, we've learned something rather disappointing. Not all exoplanets are much smaller than our yellow dwarf sun. It burns at a lower temperature. It takes stars like Proxima Centauri much longer to burn through all of their hydrogen supply. Proxima Centauri's habitable zone. That means there's the potential for liquid water and comfortable surface temperatures. If we're lucky, Proxima B would have an atmosphere that we could breathe. If it does, the surface temperatures would be in the range of 30 degrees. I don't know about you, but I'd move there right now. I just need to warn you that there are a few problems. A trip to Proxima B would be long and very dangerous. Proxima B might be the closest habitable exoplanet we've got, but that doesn't mean it's close. The red dwarf star Proxima Centauri is about 4.3 light years away. That means that if you could travel at the speed of light, it would take you 4.3 years to get there. Nothing we've built so far can reach that kind of speed. Realistically, a trip to Proxima Centauri in a space shuttle would take 165,000 years, give or take. That's right. Some of the colonists would be born in transit. Some of them would never see the Earth. Some of them would never see Proxima B. They'd just live their lives aboard the spaceship and die in space. How many humans would we need to send on a mission exactly? It's so far that we can't even see if it has an atmosphere. It might just happen that we would arrive at a frozen planet with surface temperatures of minus 40 degrees. And even if it has an atmosphere, it might not be the right one. We might still enjoy warm temperatures, but we'd be doing that in spacesuits with oxygen tanks. Or Proxima B could be tidally locked to Proxima Centauri, meaning that one of the planet's sides would always face its star, and the other side would be plunged into darkness. Spaceflight itself could bring some unpleasant surprises. Spending an entire lifetime in a zero-gravity environment would lead the crew members to lose muscle and bone density. They'd be constantly exposed to space radiation. Their microbiomes, immune systems, and physiology would all be different from ours. They wouldn't be the same kind of humans as we are. They would change their values and culture. They might forget all the farming techniques we'd teach them to sustain themselves in space and on their new planet. They might change their mind about the mission altogether and just turn their spaceship in a different direction. Who knows? They might even come back to Earth and take revenge for all those years they were forced to spend in space. If that happens, I'll be asking for a refund. Sending anyone on a mission like this is a huge risk. We'd need to design and build a vehicle, choose the space travelers very carefully, supply them with all the food and water, and make sure they could become self-sustaining. We'd have to design new propulsion, navigation, hibernation, and life support systems. And we have no way of knowing if Proxima B is actually habitable. Well, now I don't really feel like going there, do you? "635 light years from where you are sitting, way out there in outer space, lies a planet. The first planet to be discovered within the habitable zone of a sun-like star. Its name is Kepler 22b. When a planet is located within a star's habitable zone, it means there's a chance that liquid water exists on its surface. And where there's water, there's also the possibility of life. Human life. How long would it take to get to Kepler 22b? What would the weather be like over there? And why would you need to get jacked before arriving on this new planet? This is What If, and here's what would happen if you lived on Kepler 22b. Kepler 22b is what scientists call an exoplanet. It's a planet outside our solar system. Spotting an exoplanet like Kepler 22b is often not easy. The bright glare of the stars they orbit tends to keep them hidden from our telescopes. what did scientists come up with to get around it? Looking at the stars themselves to see if they can find anything unusual about them. They spotted Kepler 22b using what's called the transit method. They watched Kepler 22, the star this exoplanet orbits around, and noticed that its brightness changes over time. That was because Kepler 22b was blocking the star's light. With this, scientists were able to learn both the size of 22b and how it orbits. And it looks like this distant space rock could become our next home. Okay, but what do we really know about Kepler 22b? Its mass is 36 times that of Earth, with a radius of 2.5 times larger than ours. 1 year on Kepler 22b is 290 days. It's also located 15% closer to its star than we are to the Sun. If Earth scooched over that close to our star, you'd be fried. Kepler 22b, on the other hand, is lucky to have a sun that is remarkably similar to ours, but also smaller and cooler. This close proximity to its star allows the planet to receive about the same amount of sunlight as we get over here. The temperature on Kepler 22b could be about 15 to 22 degrees Celsius, similar to Earth's spring weather and quite habitable if you ask me. But our galaxy can be a cruel place, and not everything is good news. Some models suggest Kepler 22b is rotating on its side, kind of like our very own Uranus. This may sound insignificant, but it adds potentially deadly complications. This would mean that its north and south poles are shrouded in either darkness or sunlight for half a year. And this ain't simply a matter of whether you're a daytime or a nighttime person. A world like Kepler 22b spinning on its side means that temperatures could change from boiling to freezing, which wouldn't be great for human life. I know, what a bummer, but don't despair yet, because known about Kepler 22b. For starters, we still don't really know what gravity is like there. It could be twice as strong as our planet's. If that was the case, a 10-kilogram sack of potatoes would now weigh 20 kilograms. And your body would also factor into the mix. Is your current weight 75 kilograms? Well, good luck suddenly dealing with 150 kilograms of you. And just for safety, settlers such as yourself would need to bulk up. Really bulk up. Only through intense strength training would you increase your chances of being able to walk on Kepler 22b. And once you got jacked on Earth, you'd have to figure out ways to preserve that muscle through all 635 years of light-speed travel. But humans aren't the only life form that would be affected by a stronger gravity. Plants brought from Earth for oxygen and nutrition might not survive on Kepler 22b when you try growing them there. And if you brought any animals with you, they'd need to step up the evolution process. Higher gravity could lead to creatures developing additional legs to move around. It could also determine the location and size of internal organs. But the mysteries don't end there. Scientists still don't know for sure that Kepler 22b is even a rocky planet. It might be gaseous, similar to Neptune, or it could be entirely covered with water. If you and the other first settlers woke up from your cryosleep and found yourself on a gas planet, yeah, that would be a downer. You wouldn't have a solid surface to even land your ship, not to mention a place to set up camp. In that case, you and your crew would need to figure out how to build a cloud city orbiting the planet. If you landed on an ocean planet, a submarine town would be in order. Discovering Kepler 22b is a rocky planet would be hitting the jackpot then, right? Well, not so fast. Venus is also made of rock, and yet its dense atmosphere, consisting of greenhouse gases, makes it uninhabitable, with scorching temperatures far too hot for liquid water. If this was also the situation with Kepler 22b, our only chance at thriving on this exoplanet would be to employ robots that could build underground shelters. The place where maybe, just maybe, the temperature might be cool enough for you to bear. It just goes to show you that a prime location is no guarantee for human survival. And as exciting as it might seem to find other worlds to inhabit, our own Earth remains the perfect habitat for humanity.
The Earth may not be our home forever. Eventually, we may have to leave. What if, instead of finding a potentially habitable exoplanet light years away, we stayed in our solar system and built a habitat so enormous we could never overpopulate it? This is What If, and here's what would happen if we built a ring world in space. Imagine you lived on a ring with a radius of 150 million kilometers encircling the Sun. A gigantic artificial world with its own gravity, ecosystem, and atmosphere, big enough for trillions of humans to call home. You'd live on an enormous landmass on the inner side of the ring. The outer shell would protect you and all those trillions of people from the hazards of outer space. How does that sound? Yeah, great. Problem is, assembling such a thing suspended out in the solar system wouldn't be easy. You couldn't just pull the Earth apart and have an army of robots reassemble it into a ring world. Among the many problems you'd run into, your first would be finding the material. The International Space Station, roaming the Earth's lower orbit right now, weighs about 420 tons. Something like a ring world would tip the scales at no less than 1,000,000 tons. Where would we find all this material? I know some places. The Kuiper Belt beyond the orbit of Neptune would do just fine. This ring of icy bodies stretches out for almost 3 billion kilometers. Some astronomers think the Kuiper Belt would have enough material for this project, but it's hard to tell exactly how much we'd need to construct a thing like this. We might have to sacrifice all the planets, moons, and asteroids in the solar system. Our ring world and the Sun would be the only things left. If we could manage to gather and transport all the material available, then construction would begin. It would take a lot of physical labor, an army of robots, and maybe hundreds of generations to realize that our structure was not stable enough. Because the megastructure would turn out so enormous, it would break any known molecular bonds. We'd have to find a way to make use of one of the fundamental forces of nature, the strong nuclear force. Of all forces, it's the grippiest. It bonds material on the scale of atomic nucleus so that nothing can break it apart. Or maybe we'd come up with a new, super strong material altogether. But until we figure that out, every interstellar body passing through our solar system would be a threat to our megastructure. The next thing we'd have to worry about is gravity. And that part is pretty easy. We just have to spin the ring world at nearly 2 million kilometers per hour. I know, that's really fast. We'd have to build up that speed over time. Luckily, maintaining it in the frictionless environment of space wouldn't be too hard. Such rotation would generate centrifugal force, and that, in turn, would create an artificial gravity equal to the one we have here on Earth. With gravity solved, we'd bring in the atmosphere and start populating the ring world. For the inhabitants of the megastructure, it would always be daytime, unless we could create a day and night cycle with extra panels inside the ring. But for all the epicness of the world we just created, it wouldn't be stable. A single asteroid strike could cause the structure to drift closer to the sun. A hole punched through the ring could let all our atmosphere out. And a massive solar storm? Don't even get me started on that one. One failure inside the ring could doom the entire structure together with its inhabitants. It's just too risky to build it around the sun. Imagine living on the moon. You'd have the best view of Earth. You'd enjoy bouncing around at zero gravity and living your life as an astronaut explorer. Doesn't that sound nice? Except living on the moon won't be like this at all. So, what would it be like to actually live on the moon? Who will establish a base first? And why would moon dust be your biggest problem? This is What If, and here's what would happen if we settled on the moon. Let's make this clear. Just like America did in 1969, humans will land on the moon again in the next decade. Only this time, it's expected to be more permanent. What's less clear is exactly which country will be the first to land and establish a base. China, the USA, Russia, and India are all making strong efforts to get there. But there are also private companies, including SpaceX and Blue Origin, that have a lot more money to spend on going to the moon. But wait, why exactly are these companies doing this in the first place? Apart from exploring the galaxy and breaking new ground, there's another huge reason these groups all want to be the first to create a base on the moon. And that reason is money. The moon is chock full of different resources. It has gold, silver, and titanium in it. The idea here is to mine these precious resources and send them back to Earth. Another resource the moon has is helium-3. It's incredibly rare here on Earth, but not on the moon. That's because the moon doesn't have an atmosphere, and helium-3 comes from the sun's radiation. Over billions of years, the moon has been absorbing this chemical, and lucky for us, it can be used for energy. Helium-3 is so powerful that just 100 kilograms of it could power the city of Dallas, Texas for an entire year. Oh, and it's also worth a cool $40,000 for just 28 grams of the stuff. With these resources holding incredible value, it's no secret these countries and companies want to be the first to establish a base. But even if they do, they won't really own it. Back in 1967, the United Nations decided that no one can really own space. This has the potential to cause huge tensions between various nations, possibly leading to war. But enough about all that drama. You are on the moon. So, how exactly are you going to live here? Assuming we get to the moon in one piece, which is already an incredibly difficult task on its own, you'll then have to worry about establishing a base. Experts suggest that we live on the moon's south pole, as it gets the most consistent amount of sunlight. There are also massive fields of ice that we'll be able to harvest. Some other places on the moon don't get any sunlight for nearly a month at a time. Luckily, you'll have robots to help you establish a base. There are many different ways they'll be able to help. One includes using moon soil to construct bricks and configuring them in a dome-like fashion, sort of like a moon glue.
This would make traveling to the moon a lot cheaper, as we wouldn't have to bring everything from Earth to make our base. But don't expect this base to be glamorous. It'll most likely be several meters underground to protect you from the sun's radiation. And as for what you'll eat, well, it'll be your standard dry astronaut food. The good news is that you should be able to grow some carrots and tomatoes. A 2014 Dutch study found that it's possible using soil on the moon. And what would you drink? Unfortunately, quite a lot of it will be your recycled pee, as drinking water won't be available on the moon, and it would be too heavy to ship there. Another thing you'll need to seriously worry about is moon dust. This magnetic dust gets everywhere. It'll get on your suit and even on your skin. Previous astronauts have had allergic reactions to it. It's also slightly sharp, so accidentally swallowing any would be a huge problem. But it's not just humans who need to worry about moon dust. It can get into machines as well, causing them to overheat. Before we settle on the moon, this is one massive problem we'll need to solve. All these issues beg the question, would you ever really want to be the first to settle on the moon? You'd most likely spend your time mining and just surviving, with little time to run around in low gravity. And besides, we all know that going here is just our first baby step to get to Mars. So maybe you should just wait for that.
Of all the planets in the universe, Earth is clearly the best for life, right? Wrong. Earth may be great, but scientists have discovered a few worlds that could be even better for life. Behold, KOI 5715.01. Most of the contenders on our Superhabitable planet list aren't the ones you could visit anytime soon. They are very far away. The top spot is held by one 3,000 light-years away from our solar system. KOI 575.01 would appear to satisfy the most basic requirement for supporting life. It exists in the Goldilocks zone of its star, so conditions wouldn't be too hot or too cold for a key life-supporting ingredient to exist on its surface: liquid water. But it would also check off many boxes to be considered superhabitable. The planetary system it belongs to could be 5.5 billion years old, which would make it around 1 billion years older than our own solar system. And the planet would almost fit the size requirement. When looking for superhabitable worlds, scientists keep their eyes peeled for planets that have a mass up to 1.5 times of our planet. And they should be about 10% larger, too. This size difference would help the planet retain heat. And if its average temperature was about 5 degrees Celsius higher than Earth's, well, this planet could have even richer biodiversity. Now, being almost double the size of Earth, KOI 5715.01 might overshoot this condition a bit. Besides, studies indicate that this planet is actually colder than Earth. But there's still hope. With the right atmospheric composition, a strong greenhouse effect could raise temperatures to the desired level. And as far as superhabitable worlds go, well, we're just getting started. Approximately 2,700 light-years away is Kepler 69c. This super-Earth could be around 7 billion years old. This puts it perfectly in the estimated 5 to 8 billion year old age range for superhabitable planets. This range is based on the 3.5 billion years it took for complex life to appear on Earth. So the best chance for finding life could be on a planet a little older than us. Only this exoplanet could be a little too big to be superhabitable. It has a mass almost 4 times that of Earth. A rocky planet this big could have a single colossal continent that would have huge deserts in its center.
But the coastline, washed by Kepler's ocean, could be your perfect spot to move to. Our next super-Earth shares a similar name, Kepler 1126b, except it would be located ever so slightly closer to home. Yeah, this planet is about 2,073 light-years away, and it belongs to a system that is 7.5 billion years old. It also orbits a yellow dwarf star, much like our own. Only Kepler 1126b is 2.5 times closer to its star than Earth is to the Sun. But that's no big deal because the star Kepler 1126b orbits is cooler than ours, so the habitable zone would exist in a range much closer in proximity to it. If you aren't feeling this nearness to a scorching hot star, there's another super-Earth on our list. And it's at a reasonable distance from home. Speculos 2c is located only 106 light-years away. Not that its proximity gives it any kind of advantage. It would still take you well over 200,000 years to travel to this super-Earth. And that's if you moved at the speed of NASA's Parker Solar Probe, the fastest probe ever launched. Speculos 2c does look promising, though. It's about 40% larger than Earth. There's also the potential for it being a rocky planet, just like ours. Now, despite the fact that it also exists in a habitable zone, its red dwarf star is still very small. It's only about 15% the size of our Sun. So this planet orbits around its star at a very close distance. And this close distance could mean that Speculos 2c is tidally locked to its star. This super-Earth takes 8.5 days to make one full rotation on its axis, as well as one orbit around its star. That would leave one side of the planet in constant daylight and the other in endless night. This means that life could be possible in the Terminator Zone, the thin strip of land between the two sides. We just need to get a better look to find out for sure.
This is not some DVD floating in space. It's a megastructure that might one day become humanity's home. The Earth might not remain habitable forever. It could get engulfed by a massive solar flare, or become too hot due to climate change, or have all its life wiped out by one enormous asteroid. What if I told you we could outlive all these disasters? And that we could do that by building a space megastructure bigger than the Sun itself. Just how big would we have to make it? And what would life be like on a structure like that? This is What If, and here's what would happen if we could build an Alderson disk. Why would we colonize other currently uninhabitable planets if we could hypothetically build a habitat of our own? Something that would host many billions of future humans without ever running out of space. It does look like a DVD, doesn't it? Only it has the mass of 3,000 suns. The reason why we'd need our Alderson disk to have such a huge mass is gravity. All objects with mass are gravitationally drawn to each other, and objects with a greater mass have a greater gravitational pull. For the Alderson disk to be stable enough to host life, we'd need it to have a stronger pull than the Sun does. That's where it gets tricky, because the Sun is the most massive object in our solar system, accounting for 99.8% of its total mass. To have enough material to outweigh the Sun, we'd have to get it by breaking down every planet, moon, and asteroid in a radius of hundreds of light years around us.
Or we could give our Alderson disk artificial gravity. This type of gravity isn't caused by attraction, but by acceleration or centrifugal force. In other words, we'd have to spin our disk fast enough that it doesn't collapse into a donut or get swallowed by the sun. But since we haven't really figured out artificial gravity yet, let's stick with the first option and make our Alderson disk very, very massive. 241 million kilometers wide. That would make it stretch past the orbit of Mars. It would also be several thousand kilometers, or miles, thick, and would have a surface area equivalent to over 1 billion Earths. Just imagine how many billions of humans could live on it. But not so fast. Our Alderson disk wouldn't be habitable everywhere. And before I explain that, let me talk about the Sun for a moment. Our Sun would be sitting stationary in the hole at the center of the disk. And because of this, our disk would have no day and night cycle, only a never-ending twilight. But since our disk would have a bigger mass and a stronger gravitational pull, there's a chance that the Sun would wobble up and down. That would somewhat solve our day and night problem, but it could also increase the possibility of colliding with our star. We might need to install gamma ray lasers to have more control over the Sun's wobbling. And still, our disk-shaped world would need way more things to become suitable for us to live on it. One of the most important things is an atmosphere. On Earth, the atmosphere protects us from harmful ultraviolet radiation. It reduces temperature extremes, and it creates pressure that allows liquid water to exist. We'd need an atmosphere to do all the same things for our Alderson disk. And to keep the Sun from stealing it, we'd need to build a wall around the disk's inner edge. Unlike Earth, the Alderson disk wouldn't have liquid metal in its core to give it a magnetosphere. A magnetic field is important because it keeps the solar wind from stripping off the atmosphere. Without it, the solar wind would erode the part of the Alderson disk closer to the Sun. This could make the entire structure unstable and possibly destroy it altogether. Once we figure out how to make the atmosphere and magnetic field, we could bring in water. We'd make holes in the disk that would allow for oceans. Because of the way gravity would work on our Alderson disk, the water could be suspended. The oceans on the disk-shaped structure would literally be bottomless. For the same gravitational reasons, humans would be able to live on both the top and the bottom side of the disk. For those living on the bottom side, it wouldn't feel as if they were walking upside down. It would be just normal on each side. But of course, this space megastructure could have some flaws. Because of the disk's enormous mass, its gravity might make it collapse into a gigantic torus, or even worse, a black hole. Then there are asteroids. Even though we used up all the nearby asteroids to form our Alderson disk in the first place, there's no guarantee new interstellar space rocks wouldn't come and bombard our disk world. And not just asteroids, but rogue planets as well. Even the slightest hit could destabilize the disk and plunge it right into the Sun. Speaking of the Sun, remember I said that not all of the Alderson disk would be habitable? That's because the Sun wouldn't be heating it evenly. The inner side of the disk would be very hot. To withstand the tremendous heat, we'd have to give our disk a heat shield, just like the one we developed for the Parker Solar Probe. The outer edges of the disk would be freezing cold, but the middle band of the structure would be just perfect for life. Although there would be a lot of unused space, the habitable area would still be 50 million times larger than the entire surface of Earth. So, a giant planet with the thickness of several thousand kilometers. It might not survive in space. Make room, Earthling! We're moving the other planets in our solar system into our planetary neck of the woods. Would all the planets fit into this Goldilocks zone? What kinds of gravitational chaos would this cause? And does this mean life would exist on the other planets? This is What If, and here's what would happen if all the planets of the solar system were in the habitable zone. Liquid water is a key ingredient for life, and in our solar system, Earth is the only planet with liquid water on its surface. That's because our planet is located in the habitable zone of our Sun, also known as the Goldilocks zone. And the conditions here are just right. Any closer and water would boil away. Any further, it would freeze. The size of this area depends on how hot or cool a star is. Scientists have discovered 4,000 exoplanets within habitable zones, but only 24 of them might be able to support life. In our solar system, this zone is within a range of 0.9 to 1.2 astronomical units from the Sun. So, if we parked all the other planets within this 45 million kilometer patch of real estate, could we kickstart extraterrestrial life? With 8 planets to squeeze in the Goldilocks zone, you'd need to get creative. The last thing you'd want to do would be disrupt the conditions for life on Earth, right? Well, to start this scenario off, you'd need to move Mercury to the innermost portion of the habitable zone. At around 0.9 astronomical units, that would be more than twice as far away from the Sun as Mercury orbits now. Not much would change on this rocky planet, except for a refreshing coolness after billions of years of scorching hot temperatures. Venus already orbits relatively close to the habitable zone at 0.72 astronomical units. When our Sun was a young star and dimmer, Venus was essentially located in a habitable zone. It could even have had conditions for life, with a shallow ocean of its own. But as the Sun got hotter, that Goldilocks zone was pushed further back. Temperatures increased and the oceans boiled away. Maybe relocating Venus to a cooler spot away from the Sun could make it habitable once again. Now, it would be time to do some calculating. You've got 5 more planets to squeeze in. It could be a good idea to make sure all the planets are an equal distance apart. With our narrow Goldilocks zone, you could place each planet 6.5 million kilometers from each other. That would be equal to about 30 times the distance between the Earth and the Moon. Moving us away from our current location would make this whole experiment a little less chaotic, but at about 0.97 astronomical units, things would get warmer here. Bad news for the climate crisis. Ignoring that for now, you'd move on to Mars. You'd be excited to see if this cold, rocky planet could have life. Well, sorry to say, it would still be barren. You see, liquid water isn't the only thing that life needs to thrive. Mars lacks a magnetic field. That means solar radiation would strip away the chances of it having an atmosphere. You'd still have to terraform it. You'd likely not see any life popping up on the remaining gaseous planets either. The gas giants, Jupiter and Saturn, have atmospheric pressures and temperatures far too intense for molecules like DNA to be stable. But You could probably take a cold dip on one of Jupiter's moons, Europa. Its new proximity to the Sun would allow its thick ice layer to melt. Feeling refreshed, you'd realize that the last planet in our solar system, Neptune, is now even closer to us than Mars is today. That means, in our new solar system arrangement, planet hopping would be a reasonable adventure. Even with current technology, you could travel between the planets in 90 days. And beyond the exploration, there are all kinds of resources you could extract from the other planets. You could get hydrogen fuel from Jupiter and Saturn to help us transition to a low-carbon future. You could mine cobalt from asteroids. This would be important to developing renewable energy systems. But this new solar system would be a little unstable, to say the least, especially with a massive planet like Jupiter so close to us. It has 2.5 times the mass of all the other planets in our solar system combined. Scientific reports indicate a star similar to our Sun could have 6 Earth-sized planets within its habitable zone. With Jupiter, gravitational stability would be all out of whack, and all these imbalances could result in the planets or moons getting ejected from orbit or reshuffled completely.
It's one of humanity's most ambitious undertakings, created to extend human exploration to the farthest reaches of our solar system.
The next step in space exploration isn't generations away. It's happening right now. And our destination? That mysterious and desolate world next door, Mars. Imagine starting life over on that tiny red dot, over 265 million kilometers away. What would happen if we built a city on Mars? Would you have to live underground? How many people would you live with? And what would the Martian economy look like? This is What If, and here's what would happen if we built a city on Mars. Since 1975, the only things from Earth making claims on Mars are robots and satellites. But now, Elon Musk and his company SpaceX are looking to change that story. Their goal? To create a city with a government, trade, and culture on Mars. This plan involves 1,000 spaceships and even more brave new recruits. By surviving in lower gravity with fewer people and only limited supplies, living on Mars might change how we could adapt to dwindling resources on Earth. But with so much depending on the early stages of planning and supply runs, could life on Mars be sustainable? Every great city starts small, whether you're talking about the little fishing town of Hong Kong or a hut village named Rome. So, if you want this Martian colony to grow into a thriving city, you're going to need more than a handful of people. According to the Bordeaux Institut National Polytechnique, you would need at least 110 settlers to start this adventure. The SpaceX plan starts with 2 spaceships carrying 100 people each. With this handful of explorers, your city would have just enough people to build more habitats and research stations without putting your resources in danger. If you run out of food at this stage, that's the end of the experiment. The biggest challenge this city faces is becoming sustainable without relying on regular shipments from Earth, which will only come every few years. You see, with the egg-shaped orbit of Mars, it takes 687 Earth days to make one Martian year. Supply runs would only launch when Earth and Mars align, which happens every 2 years, to cut down on travel time between our worlds. And after this nearly 8-month-long trip, there's still a chance of losing all those supplies when the rocket lands. Since the gravity on Mars is only 3/8 of the pull on Earth, landing safely on the surface of Mars would be dangerous. And that doesn't take into account the amount of dust flying in the air. After all, the dust on the Moon was bad enough, and it got into crew members' eyes and damaged systems on their spacecraft. But kicking up the dust on Mars might be even more deadly, since each grain is highly oxidized and electrically charged. But hey, you made it to Mars safely. Now, what are you gonna eat? The chlorinated soils on Mars are toxic, and if you ingested them with your food, you might damage your thyroid gland. So that means farming is out. Outdoor farming, at least. Well, before you worry about eating, you'll need to set up protection from the harsh conditions on Mars. With an atmosphere made of 95% carbon dioxide, the air on Mars is toxic. And don't forget about the intense radiation on the surface. With more exposure to radiation and no breathable air, you won't be able to survive without a controlled environment. Thankfully, with the help of those rocks under your feet, you have all the protection you need. Just 5 meters of the surface materials on Mars, called regolith, provides the same amount of shielding from radiation as Earth's atmosphere. This material would be processed into cement to create layered walls using robots and 3D printers. This material would be a protective shell, and underneath that shell, domed science facilities, living spaces, and all your home comforts. Connected by tubes, these domes would provide you shelter from the raging dust storms outside, which might last for months. Even with this technology, Elon Musk claims it could take up to 10 years to establish a colony. But it's during this time that your quaint Martian village would grow into the first human city beyond Earth. Since this world isn't being drilled or fracked, the power grid on Mars can be made sustainable right from the start. We would set up solar arrays for electricity and use natural gases like methane for engines. Our footprint on Mars could start low and stay that way, no matter how many people live there. And now you better figure out a way to feed all these people. The low gravity on Mars might decrease your muscle mass. To keep your body healthy, you'll need to provide more protein. You'll have to serve the equivalent of 110 cooked chicken breasts and 660 carrots every day. If one of these domes contained an indoor farm, you could raise the chickens you need to feed your city. And you would have the most nutrient-rich manure available. If you used this manure in the greenhouses, you'd have a way to fertilize your crops year-round. But how could you irrigate those crops? How would you get water? Scientists still debate whether liquid water exists below the ice caps on Mars, but if it does exist, that freshwater source could be filtered for the colonists to use for irrigation. With less gravity on Mars pulling water down into the ground, you would need less water to keep your plants alive than you would on Earth, since it would stay closer to the surface. And with supplies being transported only every 2 years, having spring water available on Mars would change how the city would operate. It would create a government infrastructure to distribute and oversee the water supply and employ scientists to manage the filtration needs. Now, the city has an infrastructure in place and jobs to fill, so how would you value your time in terms of cash? How could you pay for products or services? Cash weighs too much to travel with in outer space, and credit cards would require Wi-Fi services communicating back to Earth. With a 14-minute gap in communications between Mars and Earth, you're gonna need something more locally based. Well, you might have to use a cryptocurrency known as Mars coin, but you would have need to have bought it with your Earth money before you boarded the spaceship. While Mars coin would only be available to Martians, this money would help build the government, increase trade, and create a standard of living. With society on Mars still new, maybe you could trade your services or learn to barter goods instead of relying on this cash system. If we do things right, life on Mars might be the model for future civilizations, free from the constraints of the culture built on Earth. Or it could be like every sci-fi movie ever made.
Before you go on to the next hypothetical adventure, have a look at our What If 100 book. This is your must-have encyclopedia of imaginations, a beautiful collection of your 100 favorite scenarios, amazing artworks, and interesting facts, all in good old beautiful print and paper.
One day, Mars could look like this, allowing humans to comfortably live on the planet. All we'd need to do is to terraform it. But how? Well, we could nuke it. Would dropping nukes on Mars make it easier to live there? This is What If, and here's what would happen if we nuked Mars. Believe it or not, this is something scientists have considered for decades. Elon Musk of SpaceX seems to think that nuking Mars might be one of the best and quickest options